Okay, when we have an average rate of change, like we did in class, if you have a curve, say this one, and you've got a function, say from point, say x sub 1 to x sub 2, then if you want to take the average rate of change from the function to this point through that curve, you're going to get a secant line. So let's take that secant line is this one. Then the slope of that secant line would be delta y over delta x. And we did an example using this function right here. And it's at the interval from 6 to 8. Okay, how about letter B? Okay, so from letter B, we have delta y over delta x. That's going to be, well, we need y2 minus y1 over x2 minus x1. So what is y2? Y2 is your f of, because this is going to be your x2. So f of x2, which is f of 4. So that's going to be 2 times 4 cubed plus 2. So that's 2 times 64, 128 plus 2. So that's 130. And then f of negative 4 is your y1, which is f of x sub 1. Okay, so that's 2 times negative 4 cubed plus 2. Well, that's going to be negative 128. So plus negative 128 plus 2 would be negative 126. All right, so now when we do our delta, okay, so this is equal to, just plug in 130 minus a negative 126 over 4 minus a negative 4. So this whole thing would be equal to, all right, so from here it's going to be 256 over 8, and the slope is 32. Okay, when you do all the math arithmetic there. Okay, now what's going on? Remember when we did this in class yesterday, or rather Wednesday, the slope on the interval from 6 to 8 is much higher than the interval from -4 to 4. So let's look at the graph. That way you have an idea of the slopes of the secant lines. Okay, so if you have an interval, say from 6 to 8, so if the interval is from here, from 6 to 8, somewhere here maybe. Okay, this is not to scale. We can't even draw the curve is not even in this, it's not shown in this graph, but when this keeps going, when you keep going, the slope here is very, very steep. So if you keep going up to the point where you get into the interval from 6 to 8, the slope is very the secant line is very steep, so the slope is high. So, and we've seen that when we did letter A. But in letter B, let's say suppose you're from here, so -4 to 4. Okay, so here's the curve, and that's the point, and say it meets. This is not to scale, okay? And if you draw a line, a secant line from here right down there, okay, that secant line would have the slope. Okay, so the slope of this secant line would be equal to 32. And again, this is not scaled, but you see the difference when you get this slope of the secant line from 6 to 8, that interval, as opposed to from -4 to 4. Okay? All right, now let's move on to the next example. So find the average rate of change of the function over this given interval. Now, how do we graph the function f of t equal to 15 plus sine of t? That's just the function sine of t, except it's translated 15 units right above the x-axis. So what I'm going to do, again, I'll just do something like this to mean that, you know, it's not to scale. You move up to 15. And then let's just draw the sine function right here. Okay, so let's say from, let's just do it from, well, we got to do it from minus pi to say 2 pi. Okay, like I said, this is not to scale, so that we'll just have an idea. So the whole sine function will just be translated, right, up to this. So it says, what is the average rate of change on an interval, okay, from 0 to pi over 2. So just this interval, let's see what it looks like. So you draw a line, okay, so what is the slope of that secant line? So again, what do we need? We're going to need the slope, which is change in y over change in x. So let's go ahead and that's y2 minus y1 over x2 minus x1. So y2 minus, y sub 2 right there, minus y sub 1 right here. So it's going to be f of pi over 2, f of pi over 2 minus f of 0 divided by pi over 2 minus 0. So let's see. All right, so now we get it, f of pi over 2, that's 15 plus the sine of pi over 2. So 15 plus the sine of pi over 2 minus 15 plus the sine of 0. Okay, and as you can see, and this is pi over 2, this whole thing will just be, that cancels out the 15. Pi over 2, sine of pi over 2 is 1, so and 0. So 1 minus 0 is, so 1 over pi over 2, it's going to be 2 over pi. So it's approximately 2/3, that slope. Okay, now if we take the slope, so that's for letter A, but now if we do it at B, it's just easier to just figure it out from the graph. Okay, so we take this line, this interval right here, so it's minus pi over 2 all the way to 3 pi over 2. But as you can see, that is going, this secant line is horizontal. So in letter B, m should be 0. And you can verify by doing all these, and you'll get 0 as your slope. All right? Okay, so I want you to work on that. Make sure you can verify from the graph that it's a horizontal line, so we'll have a slope equal to 0. Okay, now let's go ahead and look at the next slide. Right, as you can see, we said that it's the line. So it's going to be this line that's secant to the curve. That's your secant line right there. Okay, and we say that the slope would be change in y over change in x. Now, if you think about it, the distance from x1 to x sub 2 is h. So the change in x would be h. We can call it h. It's just a random, letter. So I can say then that x sub 2 is x sub 1 plus h. So another way of looking at the slope would be, if you see that it's going to be f of x sub, it's going to be f of x sub 2 minus f of x sub 1, but f of x sub 2 is f of x sub 1 plus h. Okay, so with that, then the corresponding y sub 2 would be f of x sub 2. So it's the same thing. Question, what happens now? What happens now when h goes to 0? So that means that this curve, this secant line will just keep on moving and inching towards x sub 0. So we take the secant line and let's move h to be closer or smaller. So it's going to be right here. So we take that line. Okay, then move a little closer, etc. Okay, so if we keep on inching, what's going to happen is this line would now be touching, as h approaches 0, this line, the secant line, would now become a tangent line. We say then that the slope of the tangent line at P would be the limit of this secant slope function. Okay, this is a slope function, and then you let h approach 0, because you see how h would get closer, or x sub 0 plus h is going to get closer and closer right here. It inches until your x sub 0 plus h, until it reaches x sub 0. Then what you've got is a tangent line. Okay, so the slope of the tangent line is just your secant line. Take the limit, the slope of the secant line, take the limit as h approaches 0. All right? Let's look at some examples.